Good morning, everyone, and welcome. Great to see you all here. I'm Chuck Friedman from the University of Michigan, and to my left is...
I'm Rachel Richardson from Duke University. Welcome.
And as an alumnus of the University of North Carolina, it is difficult for me to collaborate with Rachel, but I'm delighted that I've overcome my natural instincts.
And I didn't wear the wrong color blue.
So I hope that sets a tone for the meeting. I hope we will have very serious discussions and a very participatory and interactive meeting. And I hope we have some laughter in here today as well. We are very, very delighted to be having this meeting at the beautiful Lister Hill Center, and very grateful to the National Library of Medicine for making this facility available and for co-sponsoring this event. I'd like to now invite Jerry Sheehan, Deputy Director of the Library, to welcome us formally. Jerry.
Okay, thank you. For those who are following in the program, you'll notice we have a slight change, and that despite my best attempts, I will not be Milt Korn for you this morning, NLM's Deputy Director for Research and Education. Milt was called away unexpectedly this morning, but he does hope to join you later this morning and to stay with you throughout the duration of the event. So in his place, you have me, Jerry Sheehan. I'm the Deputy Director of the National Library of Medicine, but I'm probably equally thrilled to have Chuck and Rachel and all of you here with us for the course of the next day and a half for this topic that's, I think, of great importance to all of you and of great interest to those of us here at the National Library of Medicine on mobilizing computable biomedical knowledge. You are, of course, seated here at the National Library of Medicine, which is, as we like to say, the world's largest biomedical library, which means we think we have a lot of biomedical knowledge situated right here. If we were in the other building just connected to this one, I might say it's sitting right beneath your feet down in our archives and in our computer facilities, but still it's very close by, close at hand in digital electronic form as well as in physical form. We're at an exciting time here at the National Library of Medicine, having just issued a new strategic plan for 2017 through 2027 that outlines a number of ways in which we hope to carry this mission forward and expand this mission in ways that are very, very harmonious with the theme of today's event on computable biomedical knowledge. Number one being to position the National Library of Medicine as a platform for biomedical discovery and for data-powered health. And I think that's really what we're talking about today, and that is the number one of three themes in our new strategic plan, is to put our arms around the great wealth of knowledge, information, and data that are being generated in the biomedical research and the care communities every day, and to find new ways to channel those into research advances and improvements in clinical care. I think we're also making progress just in today's event on item number 2 of our new strategic plan, which is new forms of stakeholder engagement. I'll say new forms of engagement. How do we work with the various communities across the biomedical research, the clinical care, the education, and the general public as well, to help bring that knowledge and information to them in new, novel ways that they can make better use of? How can we also engage them to ensure that we're capturing the full breadth and diversity of biomedical information and knowledge? We, of course, spend a lot of time here on our collections, our journal articles, the gray literature as well, and increasingly on other forms in which knowledge can be represented, whether it's in data, whether it's in software and code, whether it's in the protocols that describe how research projects were conducted, in trying to find ways to make all of that knowledge more engaged. I'll just mention the third of our 3 themes in our strategic plan, the third being workforce development. How do we create a workforce of people who can make use of this information, make use of this explosion of information and the new technologies that we have at our fingertips, literally at our fingertips, to make greater use of it? How do we develop the PhD level biomedical informaticians and data scientists? How do we ensure that all biomedical researchers have some basic understanding of data science and statistics so they too can use and interpret this knowledge, and how do we ensure that the general public is in a position that they can understand the kinds of information we have at our fingertips. So I think, again, this workshop, this conference is for us very much aligned with our strategic plan, very much aligned with some of our own initiatives. As we collect more and more biomedical information, data, knowledge, code, models, you'll hear my director talk about later on tomorrow on the program. How do we make sure we understand what all of this information tells us, the knowledge that's embedded in it, and how do we put it in computable forms, knowing that none of us individually can keep up with the vast explosion of knowledge that is ongoing now, but how can we use some of the modern tools that we have in place, some of which we try to develop here at the National Library of Medicine in our intramural research programs and in our extramural research programs to help make better use of all of that knowledge, to turn it into better research and better care to help all of those around us. I'll make one final note, which is that it's somewhat appropriate that we're sitting here in the Lister Hill Center. This is one of the two primary buildings for the National Library of Medicine. Lister Hill Center was established about 50 years ago this year in 1968. And if you saw on the way in, I'm going to read to you what's inscribed on the sign. It's the words of then Senator Lister Hill, and if I can get my IT to work here, who said, "We must develop a communication system so that the miraculous triumphs of modern science can be taken from the laboratory and transmitted to all in need." And I think 50 years later, we're still working on that same charge and that same charter. And again, I look at this event as an opportunity to take that and put it in modern 2018 terms, in terms of how do we mobilize computable biomedical knowledge. So I'm grateful again to our co-organizers, Rachel and Chuck, to all of you for being here with us today. You've got a number of high-profile speakers. Eric Dishman from the All of Us program, my own boss, be kind to her and applaud her when she comes. Patty Brennan, the director of the National Library of Medicine. And of course, you're going to hear as well from Don Rucker, who's the head of the Office of the National Coordinator for Health IT today. So I think you'll have an opportunity to hear a wide variety of perspectives on the topic, and it looks like there's ample opportunity for you to discuss among yourselves how we best make progress on this problem of mobilizing all of the biomedical knowledge that we are created. So I'm here to welcome you, wish you well on the rest of the course of the day, and I'm going to spend as much time as I can with you today. And as I said, my colleague Milt Korn will be back to join you later on this morning and to help guide you through the discussions today. So thanks again to all of you, and I wish you a very successful event. Thank you.
Thank you, Jerry, very much for these opening remarks. Rachel and I are going to share the opening presentation. I'm going to lead off, and I first want to point out that we have established a Twitter hashtag, which is on this opening slide, Mobilize CBK. Even though we've capitalized a few of the letters here, the hashtags are not case sensitive. So we encourage you to tweet on this hashtag as your interests suggest. So I will be addressing the first 2 points on this main menu, the notion that, well, it's more than a notion. I'd say the foundation that we are all here to improve health. And this will bring me to use the concept of the learning health system, which I would expect that most of you have heard about and hope you are interested in, as a way to frame this point. And then I will bring in around that idea that that persistent computable biomedical knowledge, it really functions as the keystone of the learning health system, and therefore is a critical element to continuous learning and health improvement. I will at that point turn the podium over to Rachel. Rachel will talk about what we're in more detail really trying to do with this meeting, to develop a computable knowledge ecosystem and, equally important, a community to advance it. This meeting, when it ends, we hope will not be viewed as an end, but rather as a beginning of an effort to do exactly what this bullet on the slide says. And then Rachel will describe in more detail the goals and plans for this meeting that, as we've said earlier, we hope will be very interactive and participative. So to my first point, I think it's a completely safe and probably even an unnecessary statement, but I'll make it anyway, to say that what we're all about here, when you boil it down, is improving health. And everything we're going to talk about today is in service to that lofty goal. I've been in discussions with my colleagues who are in different professions and doing different things, and it's really interesting that I can say to them that it's a great source of satisfaction to me that when I wake up in the morning and think about what I have to do that day, I have no question about the worthiness of what I'm doing, because it's a perfectly safe and incontrovertible statement that what I'm doing and what you all are doing when you go to work every day is in pursuit of better health. The concept of the learning health system, which has been around now for a little over 10 years, since it was first advanced by the Institute of Medicine in 2007. Of course, the Institute of Medicine is now called the National Academy of Medicine, has really, I believe, caught the national and international imagination, both as a philosophy and an approach to achieve better health. You can find a lot of very complicated definitions of learning health systems, but I like to use this simple three-line definition to get around to the main idea. That is, health systems at any level of scale, you can have small learning health systems and very, very large ones, become learning systems when they acquire the ability continuously and routinely to study and improve themselves. Very easy to say, a little bit harder to do. You will find an extensive literature on learning health systems published by the National Academy of Medicine, and some of those are illustrated in the lower left. And on the lower right, I give you one example, a very influential article that was published by Arnie Milstein in 2013, of accumulating literature speaking to the nature of and value of the learning health system idea. Another way to think about learning health systems is through what I call anthems, things you can say to characterize learning health systems that really do promote understanding of deeply what this idea is about. And the first is learn from every health event. This takes us to the safety culture aspect of what the learning health system is about. The idea that every event, if it can be captured as data and made available to subsequent analysis and learning, provides the substrate for continuous improvement. Of course, capturing these events as data that can be analyzed is and will remain a challenge, but it is certainly a key idea underlying the learning health system. A second anthem is, and you can start thinking about how we might set these to music. I'm hoping to do that someday. A system problem needs a system solution. The idea here, and Jerry referred to workforce, is that I don't think the problem is our workforce. I think our workforce is just fine. It's our workforce is in a negative synergy situation where tremendously talented and dedicated people are in a system that is less than the sum of its parts. And therefore, if we have a system problem, we can't fix it by fixing the people. The people don't need fixing. We need to fix the system. And the last anthem goes very directly to the purpose of this meeting. I think we're all very interested in shortening the latency between the discovery of new biomedical knowledge and its widespread application in a range of practices relating to health. And there are many who believe that the learning health system, and this brings computable biomedical knowledge into play very profoundly, has the potential to shorten this latency from the often quoted 17 years by whole orders of time magnitude to 17 months, to 17 weeks, to 17 days, and maybe in the case of a public health emergency, 17 hours. So these are three anthems. And then you can think about learning health systems in yet another way, as a kind of checklist of things that one might look for if one were hypothetically inspecting a health system and trying to understand the extent to which it is a learning health system. And these are the 5 things that would be on a hypothetical checklist to determine if a health system, or the extent to which a health system, is a learning health system. Can we, first of all, make every health event available to learn from by capturing it as analyzable data? Do we do something with this? Is best practice knowledge immediately available to support choices and decisions, and not just by providers, but by patients, by managers, and other stakeholders in health? Does this health system have the capability, and does it actually do this continuously? I would suggest that any health system can become a learning health system when threatened with loss of accreditation or other forms of extinction, but a learning health system does this continuously, not just when it is threatened. Is there an infrastructure that enables this to happen routinely and with economy of scale? And a lot of what we're going to be talking about in this meeting is an infrastructure to support computable biomedical knowledge. Its management, its curation, and its dissemination. And so the learning health system concept of infrastructure also relates strongly to what we're going to be talking about today. And finally, is all of this part of the culture, that in learning health systems there is a compatible culture, and I think if we are successful in starting a movement here relating to mobilizing computable biomedical knowledge, we will certainly be moving the culture. A bit more on learning health systems as I begin to veer this discussion toward computable biomedical knowledge, is that many people believe that the key concept within a learning health system, in terms of how it actually operates, is the idea of a learning cycle that begins at the bottom with capturing practice as data, learning from every health event. We call that P to D, performance to data, into the blue, or data to knowledge component of a learning cycle, all of this around a health problem of interest, taking that data, analyzing it, making it into knowledge, and then as you get to 12 o'clock in the cycle, interpreting the results, which takes you into the knowledge to performance, or K to P, component of the cycle where you design an intervention and actually apply it, and then the experience of that application, whether things improve relating to that health problem of interest, but also data about what actually happened is then captured as one enters the second iteration of this cycle, over which continuous improvement can result. Key point here is that better health requires these complete learning cycles. And the problem is, for many of us, this is what we were taught to do. We collect data, we analyze it, we convert it into knowledge, we publish the knowledge in journals, and then we go on to the next problem, where we collect data, convert it to knowledge, and publish another journal article, and people like me advance in academia, and many of us in the room, because we've done this a lot of times. In doing so, we are leaving to others, closing the loop, doing the K to P and P to D, which are grayed out intentionally in this figure. We need to do this if we are going to diminish that latency between the creation of new knowledge and its publication of journals. So if we leave it to others, one of the reasons we see this 20-year latency is those others don't exist in large numbers. And the new knowledge in journals sits, and it sits for a long time. So we are really advocating for this and not this. When you think about a learning cycle, and this takes us to what a lot of what we're going to be discussing here today, you can think in terms of a platform, a kind of infrastructural set of services that support the operation of learning cycles and thus the operation of a learning health system. And what I have done here is illustrated what some of these services must be, aligning them on an outer circumference with the components on an inner circumference to which they correspond. I would emphasize, and I'm sure we're going to be talking about this later today, that this is not just a technology platform. This is a socio-technology platform. It's as much about process and policy and people as it is about technology, although technology plays a key role in this. So on now to the keystone role of persistent computable knowledge, having, I hope, created a foundation for the point I'm about to make with the points I just made. Having lived in Pennsylvania, I am completely within my brief to talk about keystones. So, I like the metaphor, particularly because it sits at the top, that we can think about persistent computable knowledge as really the keystone that holds the cycle together. Because if you think about it, what you really need to make a discovery system, and a purely discovery system leads to this latency, which I don't believe will get us to the finish line for better health, into a learning system, is some means of persisting what is learned up there at 12 o'clock on the learning cycle to enable the application of that knowledge to occur. And not only to occur, but to be applicable and usable at scale. And as we transition now into talking about computable biomedical knowledge, the point here is to enable this to happen at scale, we need some computable representation of that knowledge to drive the K to P, the knowledge to performance part of the learning cycle. And that means doing something differently from publishing the knowledge in journals. May work fine for a discovery system, but it won't work for a learning system. So let's talk a little bit about persistent knowledge. When Nancy Lorenzi, a little bit later in the program, introduces the manifesto, which I hope you all have seen and many of you have commented on, there's a definition of what, for our purposes, we consider to be knowledge, and I realize we could spend the whole 2 days debating this. But we are really viewing knowledge to a very large extent as a result of an analytical and/or deliberative process. And moreover, a process that holds significance to some identified community. By persistence, we mean that an explicit representation of this knowledge exists at any point in time, and I don't think I have to say with too much emphasis to the group gathered in this room that persistence does not equate with stasis. Persistent knowledge can change. It's just the representation that persists at any point in time can be different from the representation as that knowledge has matured and possibly changed quite significantly from the representation that existed before. The point of departure for this meeting, in a very real sense, is that persistent knowledge can be represented in two ways. It can be represented in a human readable form, best thought of as a book or a journal article, and I would emphasize that making a PDF of a journal article does not make it computable. It is still human readable knowledge. It cannot be executed on by a computing device. And I contrast this with potentially what can be considered a representation of that same knowledge, which we will illustrate with this figure that we would refer to as a knowledge object, which is machine executable. And we will return to this concept many times of a knowledge object and what machine executability means. So we see these as complementary. I don't think anyone in this room would advocate for the disappearance of human readable knowledge. So we consider human readable and computable, machine executable knowledge to be complementary. Both will be needed into the future. But as we think about the evolution of computable knowledge as a complement to human readable knowledge, we can think about an expansion of what the holdings of biomedical libraries will be, where heretofore they had largely had among their holdings human readable artifacts, knowledge artifacts in books and journals. And it could be the case, and I think it will be the case, that biomedical libraries of the future will add to their collections, will add to their holdings digital knowledge objects, which are machine executable representations of that same knowledge. Just to drive this point a little bit further, you can think of human readable knowledge as published in a journal. Here is an article that makes a very clear example of how to make human readable knowledge computable. This one advances a prediction formula for lung cancer as a way to offer guidance to lung cancer screening. Well, in that article is a model. In this case, it's a logistic regression model, and it's very interesting. You can in fact write to the authors of this article if you want a quote-unquote computable version of this model, and they will send you an Excel spreadsheet. I think you don't have to think about this for very long to recognize that an Excel spreadsheet, while it does represent a way of making this model computable, is probably not a particularly scalable or trustworthy way of curating and managing and disseminating computable knowledge. What we are envisioning is a mechanism that is much more sophisticated and trustworthy, and you will hear about several examples of how this is already being done in the world, that can be envisioned as a kind of pipeline which would take the human readable version of the knowledge, extract from it some kind of model which is encodable, and then programming with greater or lesser amounts of automation that encodable model into a machine executable version of that same knowledge, which will be represented in code rather than words and pictures. As Jerry mentioned, this idea is very much a part of the National Library of Medicine's 10-year strategic plan that was released late last year. And I encourage you, if you haven't read the plan and, among other things, seen its harmony with this concept of computable biomedical knowledge, I encourage everyone to do that. But we're finding this idea on the street in many other places. The finance industry discovered about 20 years ago that they were running their entire business on algorithms and models, and really were not doing a very good job of what would be called curating and managing their models on a whole subfield in the financial services industry called model management, developed to do very much the same things that we're talking about here to do for biomedicine. And we discovered about a month ago this fascinating article that appeared in the Atlantic called "The Scientific Paper is Obsolete." And this paper, which I encourage all of you to read as well, puts forward many of the same points that we will be talking about here, although not restricted to health and biomedicine. So coming back as I close to this point about a socio-technical platform offering a set of integrated services that would support learning health systems as a way of thinking about, and I think a very powerful way of thinking about why we need computable biomedical knowledge as the keystone. What we're really going to be talking about today is these services which exist to support the K to P side, the knowledge to performance side of the learning cycle. So you can think about this in many, many ways. You can think about this as you look at the services, the more specific socio-technical services that will be required to mobilize computable biomedical knowledge. You can also look at them in the context of the whole learning cycle and see how these services will stand, not as an entity unto themselves, but as a way of driving complete cycles of continuous learning and health improvement. So that brings my remarks to a close. I will now turn the podium over to Rachel.
Bear with me a second. Are these? Okay, thank you. Sorry, I can't function without slides. Let's see. We'll put it in slide presentation mode here. Okay, so welcome again, and thank you for allowing me to sort of pick up with the story here and focus us a little bit more on what we're trying to build here and what we think this ecosystem might look like and how we can build a community to advance it. So first, I want to say that there really are just a number of use cases here that I'm sure we can all imagine, certainly many, many clinical applications for knowledge and moving it into practice. And so clinical decision support in all its various forms are just a huge, compelling use case for this that motivates a number of us in this room. But these same knowledge artifacts can also be used to evaluate treatments and measure performance and plan strategy for organizations, to support research, to enhance scientific data and collections of data and information from patient records, defining computable phenotypes that could be packaged and shared and reused in a number of different applications for a number of different purposes and use cases, and the sharing of analytic packages, if you will, to perform a number of functions. Certainly public health, we can imagine lots and lots of use cases and applications for this around event detection, tools that can assist the rapid deployment of responses, support for individuals and communities in terms of health promotion, chronic disease management, and then a whole host of applications and use cases here around education, learning analytics, for organizations and individuals, training clinicians to work in heavy data-intensive environments and knowledge-intensive environments as well. So there's just an incredible range of activities that really could be supported by what we're trying to build here in the mission that we've outlined so far. One of the sort of guiding principles here in terms of how to get this computable biomedical knowledge out and usable and to really mobilize it is this concept of the FAIR principles, which has been applied widely to data resources, right? So, but the idea that this extends to knowledge is very intuitive. These knowledge artifacts and resources need to be findable, accessible, interoperable, and usable. And one approach for doing this, again, is to think of these as knowledge objects, where in the center here we have this computer processable, machine-readable, machine-executable content, but that it's surrounded by interfaces and descriptions and metadata in ways that we can find, apply, and use that appropriately. So, of course, the library plays a tremendous role in the management and sharing of computable knowledge. So as we move towards an ecosystem and an environment where we've got knowledge at the ready that can be used for all this wide variety of use cases, that we have a place that these can be curated and managed. And then we can also begin to imagine networks of libraries that will enable computable biomedical knowledge to function and grow in an ecosystem. And so that's what we're here today, is to try and work towards that, right? So we're the community, and so I want to share a few thoughts about community, but I will say that, so I was putting these together, I had them up, and my sons came in and said, "Who's that?" I said, "Oh, it's Mr. Rogers." And then the other son came in and said, "Who's Mr. Rogers?" So that was sad for me, but I'm glad this audience sort of knows this. But this gives me warm feelings and just incredible optimism about what we can do here. And so I think it's worth just stepping back for a minute and saying, what do communities have? What do communities mean? Well, they have something in common, and we're going to talk a little bit today as you get comment. We've got some common ground, I think, on background for this, and a common vision that brought us all here. So again, thank you for being here. We are just humbled to be part of this. We recognize members, if not by name or in face, but by the role that they play. So a lot of us either know each other, will get to know each other, or certainly can relate to what people do in this big space of knowledge management and use. And in communities, people talk about what's going on, right? Talk about problems, might begin to share their experience of what we did and what other people did, and then begin to suggest solutions for these problems as they emerge. And then a community, a well-functioning community can start to work together to build shared resources, to make plans collaboratively. And I think to do both of those really involves engaging a range of stakeholders. So I hope we're well on our way to that, and that was our plan for the design of this meeting. So before I go further, I want to stop and just thank this wonderful planning committee that we had. So we had a number of perspectives represented. I mean, just a terrific, strong planning committee here. Most have been able to attend the meeting. There have been a few people that have had unexpected emergencies and things that aren't here, but for the most part, they're here. And we've together had really a number of meetings and built this meeting off of a previous effort in October of last year, where we started to try and build this community. Had some working meetings where some of these ideas have been talked through and processed a little. So it was great that we have a planning committee that has been involved in this effort for close to a year. So before I go much further, I wanted to also say, get a sense of who's in the room here. So if we could, by show of hands, I know we all identify with lots of communities, and we wear lots of hats, but I'm going to ask who primarily identifies as a librarian or when in the library science field? Wow, okay, terrific, okay, great. And how many people would primarily identify themselves as an informatician? In data science, we'll throw data science in that group as well. What about clinicians? How many? Good number of clinicians, great. And biomedical scientists and researchers, primarily. Yeah, oh, great, okay, we're getting a mix. What about public health? Anybody here representing? Wow, great. Educators, anyone whose primary hat is educators? A few, okay, so, but great, glad you're here. And I think it's terrific. We've really got a good diversity here in the room. I won't ask you to show hands about how many people are either patients or caregivers, because I'm going to assume that we all are or will be at some point in our life, and I'm going to assume that everybody has struggled, had a healthcare decision to make, and needed knowledge at some point in time, and probably struggled with the ability to find the right knowledge for the right situation at the right time in the right format. And so this is what we're trying to address here. So this is great, a great group we have to start this. Our goals for the meeting are really advance, all the ideas that Chuck put forward. We want to strengthen this foundation of a shared recognition of the values and principles for mobilizing CBK, and we've started that with the manifesto, and so I hope we have a good starting point, but we want to strengthen that and really understand what we have in common and what we believe. And then we want to work through that and frame it and start to address these important dimensions for mobilizing computable biomedical knowledge. We want to grow the community. We want to develop some action plans, identify priorities, and plan for next steps. And one way we're going to facilitate that is we have a number of breakout groups with some time scheduled today and tomorrow. We've got 4 different breakout groups. And they'll correspond to, you've got dots on the tags, and we'll point you to the right place when the time comes. There's a standards breakout group that's being co-chaired by Mark Meeson and Bob Greenis and myself, technical infrastructure with Chris Schaefer and Greg Cooper, sustainability for mobilization and inclusion, Chris Dimick, Nancy Lorenzi, and Jerry Perry. And the descriptions of these work groups are in your folders. And then we have policy and coordination to ensure equality and trust with Blackford Middleton, Jody Platt, and Josh Richardson. And so we have time for these groups to work through some of these ideas. I'll run through briefly our plan for today and tomorrow, and I'll say that this really isn't your typical meeting. We have an agenda and there's things slotted. This is really meant to be interactive and participatory. So we've tried hard, and the planning committee has put a lot of work into making sure that we have a balance of giving information so that we can all be on some level footing in terms of what we know and where we're going to go, but then we want to also have time to discuss and move this forward. And we're not sure, how that will look, honestly, but we'll have some remarks from Dr. Don Rucker from ONC. Nancy Lorenzi will overview the manifesto and the process, and we'll have a reactor panel to that. And then we'll have a panel where we have folks demonstrating real applications of this and can comment on sort of the pain points of developing tools to deliver this knowledge. And it'll be a working lunch with a poster session. Then we'll have this breakout time. And I do want to highlight this is really a critical time, and we look forward to everyone's participation to really push some of these ideas forward and it really set us up even for what the activities are going to be tomorrow. We will have a little bit of an open mic session, so we want to make sure that everybody has a chance to be heard. So we'll have fast 60-second comments after the breakouts for anybody to comment on what happened in the breakout or the process, how we're integrating these together, and we will be strict on the time limit in interest of getting a chance to hear everybody and get some of these other ideas or topics in the queue. And then finally in the afternoon, we'll have a poster session with authors standing by their posters for a short time, and then everybody will be free to move to see some system demonstrations, and then we'll have a reception. Tomorrow, again, the success of this meeting really depends on people engaging in it. We'll have Dr. Patty Brennan will come and give some remarks. Then we'll have breakout sessions again to either further the action plans that we talk about today in each of these different areas, or to highlight some challenge problems. And then we want to have a chance to integrate. So we're really going to ask people to meet somebody with a different dot or different color dot and share ideas so we can begin to come together in that way. Dr. Eric Dishman from the NIH All of Us program will also come and share some remarks with us. And then we'll have a report out from these breakout sessions in a panel to integrate them. And then we'll come together and we'll decide what are the next steps? How are we going to move forward and advance this? So this is a little uncomfortable, even the preparation for this, just to say, I'm not sure what we're going to be saying and what's going to come out of these intense meetings with the breakout groups. But it's exciting, and I hope we all have a sense of optimism and possibility about this. And then how do we see this progressing, moving forward? I mean, again, the goals for this is the first, this is a first meeting, not a last meeting. So we want to continue to grow this community, and we'll talk about, how do we spread the word, how do we post and share this manifesto, and who have we missed? Who should be here that we need to include, and how are we going to sustain and coordinate these efforts? And then we want to think about also, how to continue to develop the community in our work and really harmonize what's been happening in these different groups. I mean, we have such a diversity of issues and topics and expertise here and solutions, and we need to begin to bring those together into a cohesive whole. And then we want to move to plan a range of activities to advance this and realize our vision of mobilized CBK. So with that, I'll say our charge is to move onward. We do have just a few minutes for comments and questions before we continue on with the program. So. Anybody have any comments? Chuck, did you want to come up here and field comments or questions as well? If we get any, we don't have any yet, but I'm hoping people people will. So we've sort of laid out a vision. We've got time to really look more closely at the manifesto and, of course, have the detailed discussions of the groups. But in terms of impression of people here, how the meeting's going to flow, concerns of layout, anything that people want to share, things people are excited about. We didn't think we'd be early. Okay, yay, we got
I'll break the ice. Preston Lee from VA and Arizona State University. Yeah, I had a question. I guess, is there an intended vision of MCBK as an organization? I mean, is it meant to be informative to standards bodies? Is it going to be developing some perhaps itself? I mean, what is kind of the long-term organizational vision?
No.
Okay.
No, more seriously, I think that should evolve out of this meeting. As Rachel said, we are really not, at least I hope we're not, predetermining a specific direction that this will take. I think our intent, as Rachel said, is to form some kind of multi-stakeholder community around a sense of common purpose that will develop out of this meeting. But exactly what form that will take, we hope will flow from the two occasions on which these breakout groups will meet. We did have, as Rachel alluded to, a prior meeting in October that was a smaller invitational meeting that I think we always had in mind when we had that meeting would lay the foundation for a larger open meeting that we're having today and tomorrow. Out of that earlier meeting flowed the conceptualization of the 4 breakout groups, dividing the problem into 4 distinct but yet complementary parts. So we've tilled and fertilized the soil and thrown a few, and I guess you all will throw the seeds in there and we'll see what grows.
Maria Schatz, National Institute of Environmental Health Science. How do you see the mission of this organization different from GA for GH or RDA? GA for GH being Global Alliance for Genomics and Health, or Research Data Alliance, RDA, which I guess doing more or less the same thing. Like, why is another one?
Yeah, I'm not as familiar with the details of that, but I think just to sort of reiterate your point again, I think we need to come together and decide that. We don't have a prescribed plan of what this will look like. I think we don't want to build
yeah, but also as I understand the organizations you're referring to, I think the scope of the data and knowledge that their work encompasses may be more narrow than what we are envisioning here. I think it will be interesting to get your viewpoint on that as these discussions unfold. Clearly, any organization with genetics in its or genomics in its name implies a focus on certain types of data and knowledge, and of course everything relates to everything else, so you can expand from there. But let's leave it as an open question, what the relationship is between what we're talking about here today and what other organizations are doing, and not just the organizations you mentioned.
Blackford?
Good morning, Blackford Middleton. You know, Chuck and Rachel, it's a great program and really looking forward to the 2 days and learning a lot. I guess one thing, though, I'm struck with in its absence is discussion or consideration in a deliberative way, if you will, about how we ensure that these knowledge artifacts, both human readable and computable, are readily available and shareable economically. I'm worried about the IP issues that kind of bedevil this work, have bedeviled this work in the past. And could we imagine a day when the digital library at the NLM, for every publicly funded research project, has not only the data set with which that research was done, but also perhaps a derivation of the knowledge artifacts created by the research?
So Blackford, let me turn to our sustainability group chairs, Jerry and Chris, just to confirm my sense that that is very much a part of what the sustainability group will be looking at. Where are Jerry and Chris? Do you agree with me?
Yeah, thank you for the comment, Blackford. We'll certainly be taking that up in terms of the kinds of stakeholders we need to be accountable to and for, so thank you.
And I would add Jerry Perry, University of Arizona, thinking about this whole notion of the IP issues. I wonder if we might want to also have an open science framework kind of attitude as we think about where this might go. I think that's an interesting model, the way that has sort of arrived on the landscape, which with a goal of connecting the entire research cycle. Well, where does this fit in that space? I think that could be a very interesting conversation.
Thank you. We have someone waiting very patiently in the back there.
Hi, this is Leslie McIntosh with the Research Data Alliance. And I was just going to comment on the question. So I'm excited about what you guys are doing. What the Research Data Alliance is focused on is developing recommendations at a global scale focused on data across all disciplines. And the GA4H, which we're aligned with, is focused more on building out recommendations, where I see this sweet spot as really building out the whole process. And so there's definitely some nice alignments. And I also just wanted to make sure that we are involved in talking about not duplicating efforts and trying to understand how this can work together.
Hi, Peter Goodham from the Global Alliance for Genomics and Health. Since I've been mentioned twice, we've been mentioned. We've very much, ever since I think I saw your presentation, Chuck, in Washington about 3 years ago, we've been using this learning health system as a framework for how we would play our role in the bringing together genomic research into healthcare. And it's very much at the top left of your circle and moving it over the keystone. Very much for genomics, but also it's global. So we focus on the interoperability and the standards and the policies that will enable learning to come from one system into another system, not just within a single closed system. And that's where the real complication comes.
Thank you. I hope my talk was a little different than it was 3 years ago.
It's evolved.
But thanks for that comment. I just want to emphasize there is no intent to duplicate or disrupt in a negative sense any of the worthy efforts that are already ongoing, but hopefully to synergize with them.
Hi, this is Janos Mati from Vanderbilt. Was there a slide on FAIR knowledge? Was it the abbreviation? Yeah, so I would have liked to see something along the notion of conciseness or harmonizing knowledge, because it's one of the prevalent things that I happen to see is that people take good efforts in representing knowledge and formalizing knowledge, but I see rarely any mention on how to harmonize knowledge and how to identify identical or highly overlapping efforts, and not just in terms of approaches, but generated knowledge artifacts. And we struggle with, from EHR implementation to research topics with that notion. So that's just a comment or a discussion item that I would like to see.
And what group are you going to?
The technology group, I think, or technical.
Okay,
Yellow.
It could certainly fit in there, but
Yeah,
also.
but I was also thinking the policy for ensuring quality and trust. So Joden Platt and Blackford Milton and Josh Richardson, those topics should come up
Yeah,
there
and
as well.
somebody mentioned sustainability, and I see it as a
Yeah.
problem of sustainability.
Yeah, I think that's why we had this integration time, because I think we are going to see topics come up in multiple groups, and we will need to harmonize our plan. But this idea of quality knowledge, timely knowledge, how to represent that is on the radar, very important.
Okay, we have time for, well, we'll take two more quick comments in the front here. Yeah.
Davide Sotara, Arizona State University Mayo Clinic. Just to add to Jano's comment, not only the problem of harmonizing knowledge, but also composing knowledge. If we're dealing with not one computable object, but dozens, if not hundreds of computable objects, how do we guarantee they play nicely together? That's becoming an important issue discussed in a few venues.
Bob?
Bob Greenis, Arizona State. Seems like a block here. The comment on genomics kind of reminded me that we have an issue and a tension that we have to kind of address of, for example, in the standards breakout, which we'll talk about later, being particular or so general that it's useless. And I think what will be important is to try to identify use cases that kind of allow us to bring forth general principles of sharing, but not to be so high level that you can't see how to apply it. So it's just something to keep in mind.
Okay, thank you. Thank you. There's clearly a sweet spot here, and you're okay. So it's a bit dark in here, but I think I see Dr. Rucker to my right. I'll just give a very brief introduction. There isn't a word in English for the relationship between two people who share having served in the same organization. So I have no word to describe the relationship between Don Rucker and myself. I was the Deputy National Coordinator for Health IT and Chief Scientific Officer of the ONC for a number of years, and Dr. Rucker is the present National Coordinator for Health IT, and we're just so delighted that he's here because the role of the ONC is so clearly central and fundamental to what we are about in this meeting, not only to figure out how to do something, but also to figure out how to do something at scale. So this very much brings in the role and function and mission of the ONC. And Don, we're just so delighted that you're here. Thank you very much.
Thanks, Chuck. First of all, it's impressive to see this many people here thinking about what is truly a thorny issue, right? I mean, when you think about the representation of knowledge and making it computable, this is really hard stuff. And I think it's always been hard stuff. And I see some folks here in the audience that I was grad students with. I think it was hard stuff when we were grad students. And I see Mark and Greg here, and there's probably some other folks, Blackford. You know, it's always been hard stuff. So let me talk a little bit in the minutes about what ONC is doing to, I guess, sort of make, you know, for want of a better analogy, some fertile soil here, right? So you can compute on things and have the data and think about the different knowledge representation strategies, all of which ultimately need to be fed by data. And I think there's a couple things to put out there for, the first is, I know this is obviously a very academic audience, but laws have consequences, and the 2016 21st Century Cures Act passed December 2016, I think actually sets up a much easier and more computable environment for medical data than I think we had before. That was an extraordinary bipartisan effort. I think 390 plus votes in the House, 90 plus votes in the Senate, signed by President Obama. I can absolutely assure you that President Trump and Secretary Azar, Seema Verma, myself, we're absolutely on board with this law, and getting it out there. And there are a number of interesting provisions, I think, from an informatics point of view in there. One that's a little bit of a sleeper is actually a call out to try to figure out some of the provider burden work. And you might actually ask yourself, well, exactly what does that have to do with computable medical knowledge? But the issue is that the substrate of much of what we expect to do is really the electronic medical record. And as everybody who practices knows, the electronic medical record has become an intellectual wasteland, right? I mean, the text in that thing, you know, the notes in that really have a scant representational verisimilitude, right? I can't use a word like that in any other audience that I've ever in, so I figured I'd use it here, right? But they don't really represent the patient, right? It's sort of a funny artifact of billing, and it's just a surprising tool. It doesn't have the things that we would expect. It doesn't have, sort of an ERP sense of the enterprise. It actually doesn't really do automation. There's some things, lab retrieval, computerized order entry, but it's pretty stunning that we have all these computers and near zero automation in healthcare. So I just throw that out because I think this is part of the role that you can fill. The Cures Act has a specific component on burden reduction, and a joint report with CMS and ONC on burden reduction. And, a report is one thing, but I can absolutely assure you that HHS, CMS, and ONC are extremely interested in provider burden reduction. And if I were a betting person, I think you might see some very specific things there in the not too distant future. So for those of you who parse federal official talk, you can ponder what that might mean. But we have a lot of burdens, and they're sort of complex. And, don't just think of the work you're doing here in a classic decision support sense, but think of it sort of in a broader economic context. For example, can the knowledge you represent help with the immense burden of prior authorization? There's a massive dead loss to the U.S. economy, the healthcare economy, from prior authorization, right? Can we have enough computable data in there, and can you represent the computable data in a way to get at that burden? So I throw that out as a challenge. There are a couple specific things on information flows in the Cures Act that are worth noting. And there are probably three broad things that Congress did to get information flowing more freely. The first is a prohibition against information blocking. There's been a lot of discussion, I guess, for want of a better word, about getting clinical data. Now, all of this, by the way, is under the current HIPAA law, right? So, driven by the patient's absolute right to access their data, as well as what are called the covered, the covered entity, the business associates in HIPAA, the treatment payment operations type of data. So all under current HIPAA law. But even under that, a lot of data is siloed, and the information blocking rules basically say that's not legal anymore. The feeling of Congress is quite clear. We paid for this data, and the relevant appropriate people should have access to the data, starting with the patient getting access to their data in an electronic way that they can take their data and go elsewhere and shop for care and control their medical lives. Of course, again, another big thing for computing, right? Because once the patient owns the data in an app, then you can actually start thinking about a direct conversation with the patient, a direct computational conversation with the patient, rather than this sort of third-party parental relationship that we've built in American healthcare over the last 5 decades. The second provision is the Trust Exchange Framework Common Agreement. This just for folks' information is getting the various networks to talk together. We've had various conversations, I know, with folks in the room here about what some of those things might look like. There'll be language out on that. All of the language I'm talking about is coming out in a series of rule announcements over the course of the next couple months. The Trust Exchange Framework Common Agreement, you can think of as a network of networks. Again, it's really the concept of getting information out, sharing information, and having that be a more practical thing for providers to do. Right now, there are a whole bunch of boundary conditions on these networks, including probably one that's not 100% obvious, because we've always thought about interoperability in a very narrow way. Maybe not always, but for most folks in the U.S., I'm saying this audience, which is obviously a computing type of audience, but for most folks, interoperability means just getting one record from one provider to another provider. That's an extraordinarily narrow sense of the world, compared to what modern networks do. If you reflect on the internet and all the kinds of transactions that can happen, that very limited permitted purpose approach is really a bit archaic. So you're going to see a lot richer set of permitted purposes, and many of these permitted purposes include payers, because ultimately the provider system has to be accountable. Much of the interoperability discussion, I think, is really more about the lack of affordability of healthcare, frankly, than anything about interoperability. It's, reaching, maybe it's been for quite a while, crisis proportions. It's becoming part of the American political scene to discuss it. Solutions are difficult. Some of you may have seen the little blurb in Politico and the number of people who are now making their living on healthcare reform discussions. But that sense of network is still out there. So besides information blocking, besides the Trust Exchange Framework Common Agreement, the third provision in CURES, which is, I think, the most direct for this audience, is the concept of APIs without special effort, so open application programming interfaces. If you're going to hook up to some set of EHRs, EMRs, as a practical policy matter, you have to have some kind of standardization on interface. Otherwise, this just becomes an exercise in sort of oligopoly and monopoly and all kinds of, tie-in behaviors if you don't at least have the promise of accessible open interfaces. Congress was extremely explicit in interfaces without special effort. So that, again, rulemaking in progress, but clearly when you look at the language and the assumptions of the modern internet economy, that means using standards, right? So in a web world, we're evolving to RESTful, JSON, FHIR, everybody knows those kind of things. Obviously, we have a number of things in place, and there'll be some long transition, no doubt. But moving to open computable standards is going to be critical. That will be a requirement of every EHR that they have those type of endpoints made available. And the goals of those endpoints, the obvious one is that patients can take an app of their choosing and attach it to the EMR and download their data. And under HIPAA, once they download that, they can do with that data whatever they wish. So just to be absolutely clear, there's another important thing in the same tradition, or in the same sort of conceptual space on open APIs, which is the concept of population health. So right now, we do not have computational interfaces to get data out in bulk or batch mode out of EHRs. We simply don't have that. If you're, let's say, a payer, for example, or you want to do some kind of a roll-up of learning healthcare systems, to get data out of over a broader swath of providers, you can either go and say, give me a series of quality measures that you negotiate and compile. And I would say our track record on quality measures has been fairly problematic, right, as a country. If you sort of look at what we've done and the amount of energy and dollars we spend on them for what we actually get, it's a pretty problematic thing. And, you know, I mean, for example, all the New England Journal op-eds on readmissions data, just to give you, if you want a flavor of that whole discussion. Or the only other way to get is to do custom queries. So one-off custom queries to get data out. A number of the payers and other folks, HL7, the fire group, are working to do population level queries. You know, you call batch queries, bulk queries. Anish Chopra calls it flat fire. But it's really a way to get data out. And this is central to the learning health system concept that we've all been talking about. So as we look at computable knowledge, I think there are some very interesting things on getting data out. The initial efforts are really honestly going to focus more on the reading part of getting data out as opposed to read-write. But over time, we can certainly imagine stuff like CDS hooks and some of the other technologies that maybe you're working on being incorporated. I don't, you know, they're not immediately, I think, at a point where we can put them into any kind of, you know, meet the very, very, very high standard to put these things into federal rules and regulations. But, you know, maybe over time we can come up with some shared national understanding of those things. Hopefully won't actually require regulation, but I think that's the whole point of this event. And I want to congratulate all of you on, you know, the effort and the interest to be here, and Chuck and Rachel for organizing something like that. And thank you very much. I think that probably takes up the 15 minutes. Yes, thanks.